All right, be quiet, please. Derivative graphs. Okay, this is a very visual exercise, and you actually have to think. All right. So if this is a graph of, let's call it f of x. Okay, what does the graph of the derivative look like?
It's the tangent, right?
Yes, it's the values from the tangent line, though. Okay. So
What is the zero it crosses?
what is the value, the slope of the line at 1? Okay, 0. The slope is 0 there. That means the point here is 1, 0. So this 0 becomes our y value here. The x stays the same, but we're just taking the slope and making it a y value. All right, so what's the y value of that at 4? Okay, so 4, 0. And what's the y value here? 0. Yeah, 7, 0. So we know where it crosses the x-axis, right? You with me?
Yes.
All right, what is the slope? And that's from here to here. Negative or positive? Okay, negative slope means you're below the x-axis. It's a negative value. So on the left side of 1, we're below the x-axis because the graph is decreasing. What about between 1 and 4? And the graph, the value of the slope is positive, right? So that means, and we have to connect the 1 and the 4 because we know that it comes back down. So
Wait, I don't get it. So it goes,
the value of these slopes are positive slope, right?
yeah.
They're positive. So that means all the values from 1 to 4 are going to be positive.
Oh. Oh.
You just have to make sure you connect the 4 again because you know that's a crossing point.
Okay.
And then what about through here? Slope is, again, down back to 7 because it crosses there. And then here the slope is positive again.
Okay, so values 4 from 7 and negative on that left one is why you're doing positive.
Right. Okay, that's generating the graph of a derivative from the function. Okay, draw the derivative, the graph of the derivative of g of x on your own.
Word processing.
Okay, here it is.
Oh!
Decreasing towards a negative slope on the left and increasing towards a positive slope.
Okay, here's the interesting part. Okay, what's the slope of a tangent line at that point, Belcia?
0.
0, so we put a point at 0, 4, 0.
Oh.
The slope is 0, so the new value is 0.
Oh, okay.
Now this, what are the slopes here? Negative or positive?
Negative.
Negative, so we have negative values.
Okay.
And then the other one's increasing positive, so positive values.
So your slope, whatever your slope is, where you plot your data.
Yes. Okay. Here's what's interesting. This is a quadratic, right? Use the power rule. The new one is linear. Okay. So there's an algebraic connection and a geometric graphical connection, right? Okay, you're gonna get some more practice on those. So
I'm not a mental person. I don't like it.
Making sense.
okay, here's the last concept in this section. This is very important. Bombshell, kaboom. It's the Moab bomb. If
The only thing I got out of the station is wasn't really good.
if f is differentiable at x equals c, then f is continuous at x equals c. If you can take the derivative, you know it's continuous. If the derivative exists, it's continuous. Okay. Yes, it means it has a derivative. Because I haven't defined that. Okay, the derivative exists. Does anybody know what the converse of that statement is?
Stoichiometry makes me want to freak out. Stoichiometry. And they're kind of free.
Okay, true or false?
True.
False.
Okay, we're keeping a tally
It's the
here.
other way around. It's gotta be the other way around.
I'm saying.
Nah, man. 100.
3 trues and 1 false.
Anybody else care to vote in our rigged election?
Maybe I'll go with false.
I think it's false.
Indifferent. I think,
I'm running out of fingers here. Okay. Okay, those of you that say true, why?
I choose false.
I know you did. And those of you that say false, come up with a counterexample.
If it's differentiable, then there has to be a point there, so it has to be continuous.
Yes, that's what the first one says, Corey. But this one is not saying that. This says if there's a point there, it has a derivative. Can you think of a counterexample?
Yeah, the derivative, even if it doesn't exist. The one that was like when I went like this.
Beautiful. You had a question on your homework that looked like this. Is it continuous?
At what point?
No, let's do some integrals. But 3 is not differentiable. Let's see. I don't know how I remember.
Perfect. Okay, so you can't go backwards on that statement. If it's continuous, it does not mean it has a derivative. Okay, here's a perfect example, another perfect example. Absolute value. Absolute value of x minus 3 in that one, of course. But, okay, those are continuous, not differentiable. But if it is differentiable, it has continuity. Okay, last example here. Okay, show that f of x is not differentiable at x equals 0. F prime of x.
Oh, we can do the power.
Define different.
1/3 x to the negative 2/3
Wait, you minus it?
minus 1.
So wouldn't that also be 1/3 over the cube root of x squared?
No. What you need to know is what happens if you plug in 0 to a denominator there. Yep, f prime at 0 is 1 over 0. Okay, so therefore,
Oh, we have to write off?
okay, something of that nature. It doesn't have to be that windy. What does that mean about the tangent line?
That is,
There's
it's not continuous,
there's not a point
it's
there.
not differentiable. It's
If you have undefined slope,
it's either,
Is it vertical or not? Is it vertical?
it's vertical. Vertical would be defined because that's like 1 or 2 and 3. But then it gets to 4,
Let me just vertical.
Think about it. Slope is undefined. Vertical line.
We're talking about a slope, not an x equals. Yeah, but there's no slope to that.
There's the graph.
Okay.
Well, that's actually kind of a poor drawing. Let me draw it better. Yeah, you keep your, never mind.
No.
So think about it this way. This is the graph of x to the 1/3. It transitions from, okay, you good? All right.
Homework time. General everyone.
This is not due until Tuesday. I'll be gone tomorrow, so I'm giving you some work about velocity and speed.
So we're not doing the 25.
No, it's due Tuesday.
I actually wrote the 3 marks for my grades. I have no idea.